Hi, I'm Mr. Brown, and today we're going to start a series on quadratic equations. This particular video, we're going to discuss the history of quadratic equations, how far back they go, and give an example of the earliest known example of a quadratic equation. So I hope you enjoy it. Did you know that the quadratic equation may be one of the most essential equations for mathematics and science? Isaac Newton used quadratic equations to derive his laws of motion. The next time you watch a ball game, the trajectory of the ball as it travels through the air is described by a quadratic equation. It's been used to determine the elliptical orbits of planets, to design speakers, even to design brakes on cars. And today, we're going to start learning about this amazing equation. Quadratic equations were found on Babylonian clay tablets dating back to the time of Abraham and Sarah. We're talking about 1700 BC. We find evidence of them in India about 800 years before Christ came to this earth. We see them in Chinese culture in the 2nd century BC. But perhaps the Greeks were more instrumental in developing quadratic equations. You see, when we speak of ancient Greeks and mathematics, we're really speaking in the context of geometric representations. The Pythagoreans, in fact, whose founder was the discoverer of the famous Pythagorean theorem, literally turned trigonometry into a religion. Other cultures would bring mathematical symbols, numbers, algebra into use centuries later, but the Greeks believed the purest form of reason and philosophy was embodied in geometry. It is believed, in fact, that the words, "Let no one ignorant of geometry enter," were engraved above the entry of Plato's Academy. Here's an example of how ancient civilizations would use a quadratic equation. I want to review at the end of this video what we discussed at the very beginning. The very first thing we talked about was of course, in the history of quadratic equations, was its first appearance. It was found in I think you will recall, was found in a cuneiform tablet in Babylonia, and dated about the time of the patriarchs, Abraham and Isaac and so forth, the Old Testament, 1700 BC approximately. On that first slide I showed you, there was some writing where on the tablet, and then I translated it in English. This was what was found on the tablet, the first example of a quadratic equation. Now let's read the problem and let's see how it's solved using the Babylonians' need to use a quadratic equation. A rectangular plot of land is 20 yards longer than it is wide and has an area of 800 square yards. What are the dimensions of the plot? Well, let's write down what we're given. It's a rectangle, right? It is 20 yards longer, let's write that information down, than it is wide, okay? So here's its width. We don't know what it is yet. And it's 20 yards longer than it is wide. So this, from here to here, is x, some unknown. And here is x plus 20, because it is 20 yards longer this way. Another bit of information we're given in this problem is it has an area of 800 yards. That means the area, what's inside, is 800 square yards. We're all on the same page? Good. So how would we solve this problem? This is what the Babylonians were faced with. And what is the formula for the area of a rectangle? It's width, which is x, times height, which is x plus 20. That is the way to find an area of a rectangle today as it was in 1700 BC. And we know, because it's told us, that that area equals 800 yards. So let's work this out, simplify it as much as we can, and then solve it. Now we know from the rule of distribution rule that anytime you multiply over two or more terms, you distribute across them. So x times x is x squared. Distribute across, do the same to this one, plus 20x equals 800. Now let's move the 800 over to the other side, and I'll explain to you in a little bit why we're doing it. So to do that, very simply, we just subtract 800 from both sides to make this 800 0, because 800 minus 800, right? So we have this equals 0. We can break this into a factor. This is why it's called factoring. X plus or minus, we don't know which yet, something, times x plus or minus, once again, we don't know whether it's plus or minus yet, times something is going to equal 0. Now, what happens when you set one of these, this bracket or this bracket, to 0? Anything times 0 equals 0. So if we can get one of these, this bracket or this bracket, to equal 0, we know that we'll solve the problem because it will automatically equal 0. Now, in factoring, you take this number or this one. You got to find two numbers here. So when multiplied together, these two numbers, which we don't know what they are yet, must equal the coefficient in the third term. It's term 1, 2, 3. Negative 800 is the coefficient. Okay. And we have to, those same two numbers must, when added together, must equal the second coefficient. This is the second coefficient, right? 1, 2, 3, second coefficient. So what two numbers, when multiplied together, equal 800? Well, I know that that is going to be, I'm going to say 40 and 20 equals 800, but one of them has to be a negative because a negative times a positive equals a negative. So I'm going to make that a negative 40, 20, and then we're going to test it to see if we pick the right two numbers. Negative 40 times plus 20 equals negative 800. So we got the first part of the test solved. And then 40 minus, or 20 minus 40, that equals minus 20, but we need plus 20. So let's change the signs. And now 40 minus 20 does equal positive 20. So we have the right numbers. Now, let me move this over here. Finish the problem here. Let's write this back out again. Equals 0. So what value of x? We want one of these to be 0. And because either one of them can be 0, we're going to have two possible solutions. What minus 20 equals 0? 20 minus 20 equals 0. So x equals 20 is one possible solution. And what plus 40 equals 0? Well, that's negative 40. Either one of these would equal 0 when multiplied with the other would give us 0. Now, let's think this through. We can't have a negative area. You can't have a negative length. You can't tell someone, I'm negative 5 feet tall. No, no, that doesn't exist. So this one automatically cannot be used because we're dealing with area and with length, right? We cannot have negatives. So x equals 20. So back over here, this would be, let's plug the number in and see if it works. That's 20. 20 plus 20 is 40. Now let's just double check to make sure, see if we got it right. If we have a plot of land, that's 20 by 40. Would it equal 800 yards? Well, we know the width times length equals area. 20 times 40 equals 800. Done. So we've solved the problem. This is the earliest example that we know of the use of a quadratic equation. Now, we're going to segue into the next video, and we're going to work just on this type of solution, solving a quadratic equation using factoring. So come back to part 2, and we will cover every possible means of factoring quadratic equations so that you will be an expert on the subject.